Hi. In this lecture, we're going to introduce something called a measure of dissimilarity, an index of dissimilarity. We're going to use that to look at different cities and different regions and ask how segregated they are. So remember in the last lecture, we looked at Schelling's segregation model, and what we saw is that people who had fairly tolerant thresholds for living with people of different income groups or different races still ended up being segregated. And so the result is when we look at cities across the United States, we see substantial segregation by income, we see substantial segregation by race, and we want to know, what we want to do here is sort of figure out, can we construct some sort of measure, some way of, categorizing numerically how segregated a particular city is along a particular dimension. Because when you have those measures, right, that allows us to make, better sense of data, right, to use and understand data better, and that's one reason why we model. So to get started, let's remind ourselves again of just what these patterns look like. So this is the city of New York, and remember that regions that are depicted in red are predominantly Caucasian, regions that are depicted in blue are predominantly African American, yellow predominantly Latino, and green predominantly Asian. So New York is interesting because it's just like these big chunks of different racial groups spread out all over the city. Not all cities look the same way. Here's Los Angeles, right? Los Angeles has this area called the Valley, which is mostly white, South Central, which is mostly African American, and then over by Monterey Park, it's mostly Asian. If you look at Houston, again, you see all these sort of interesting patterns in how people are racially distributed across the city. And if you look at D.C., it's almost like there's a dividing line. To the east, most people are African American, and to the west, most people are Caucasian. So different cities look different ways. What we'd like to do is have some sort of number for representing this racial disparity. Okay? Now remember, the same is true for income. So we can use the same for income disparity. And if you look at a city like Chicago, what you see is that red represents wealthy people here. So there's wealthy people along this area known as the Gold Coast. In the center of the city, it's mostly poor people, and then to the north and to the west in the suburbs, right, sometimes called collar counties, right, so it looks like a collar, these again are wealthy people. Again, New York, remember the red dots here represent rich people, people who make more than $200,000 a year. All around Central Park here you see wealthy people, and as you move further out from the city, you see poor people. So it's interesting, New York is sort of a little bit different than Chicago in that right in the center of New York there's a lot of wealth, and then as you move out it gets poor. Chicago sort of looks the other way. So what we want is we want some measure for how segregated a city is. So we're going to construct a very simple measure called the index of dissimilarity, and we're going to do it with just two types of people, rich people and poor people. So I'm going to represent rich people with blue dots and poor people with yellow dots. Now I'm going to place these people on a grid. So I'm just going to have a 24 city block area here, and in each block I'm going to put 10 people. All right, so let's start out, and let's suppose that in 12 of these blocks right here, I put all rich people. And in 6 of these blocks, I put all poor people. And in 6 of these blocks, I put half poor, half rich. So what does that give me total? Well, remember, so I've got 12 blocks here, and I've got 10 people per block. So that's 120 rich people here. And I've got 6 blocks here, but there's only 5 rich people per block and 5 poor, so that's 30. So 120 plus 30 equals 150. So I've got 150 rich people, and then I've got 90 poor people. So 240 people total, 150 rich, 90 poor. And I want some way of representing how segregated are these city blocks. Now the interesting thing is these districts here, these green ones, are less segregated than these blue ones and these yellow ones. So I want some measure that will capture that fact. All right, so how do I do it? Well, what I'm going to do is I'm going to do this. I'm going to let B be the number of blue people in a block, little b, and let big B be the number of blue people total. So then if I take little b over big B, that's going to tell me the percentage of blue people in that block, right, relative to the total number of blue people. So it's just giving me some sense of the proportion of the total number of blue people that are in that block. And similarly, little y over big y is giving me the proportion of yellow people in that block. Now, why do I want to do that? Why do I want to look at these two numbers? Because if I take the difference between little b over big B and little y over little y, that's going to tell me how distorted the distribution is in that particular block. Let me be more precise. Suppose I have a district that has 5 blue and 3 yellow, and I want to add, this would be a perfectly representative district. What that would mean is that 5 over 150 there's 150 blue people, and 5 of those 150 people live in this particular block. So 5 over 150 equals 1 over 30. So 1 out of every 30 blue people lies inside that block. Now there's 90 yellow people, and 3 out of the 90 yellow people live in that block. So 1 out of 30 yellow people live inside that block, or poor people live inside that block. So 1 over 30 minus 1 over 30 equals 0. So what we get is that if you had a perfectly representative block between rich and poor, what I'm calling blue and yellow, we'd have a difference of 0. But if we've got relatively more blue or relatively more yellow, since I'm taking the absolute value, that's what these two lines mean right here, the absolute value, it means that I'm going to get a positive number. So I'm going to have more, I'm just going to represent more segregation. So let's look at our particular example. So this block right here is all blue, right? So and there's 10 blue people in there. Now there's 150 blue people total. So 10 out of the 150 blue people lie in that block. There's no yellow people, no poor people in that block. So I've got 10 over 150 minus 0 over 90. So that equals 10 over 150. I can get rid of the zeros. It equals 1/15. So in every one of these blocks, my index is going to be 1/15. Now in these yellow blocks right here, there's no blue people. There's no rich people. So that's 0 over 150. But there's 10 yellow people or poor people. So that's 10 over 90. So there's way too many yellow people than there should be proportionally. And so if I take 0 minus 10 over 90, I get 1/9, right? Remember, because I've got these absolute value signs here, so everything becomes positive. So in these districts, these blocks are 1/9. Then finally, I've got these green districts. Now remember, these have 5 blue, so that's 5 over 150. And they've got 5 yellow, so that's 5 over 90, right? And I take the absolute value. Now what do I get there? Well, that's 1 over 30 minus 1 over 18. So this is complicated. We're going to find out that this is equal to 1 over 45. Okay, so this is 1 over 45. What we get then is every one of those 10 blue districts, the index of dissimilarity is 1 over 15. Every one of the yellow districts, the index of dissimilarity is 1/9. And every one of the districts that's 5 blue and 5 yellow is 1 over 45. Okay, so how do we figure out how segregated this whole region is? What we do is we say we've got 6 districts or blocks here that have a dissimilarity of 1 over 45. So we're going to get 6 times 1 over 45. Then we've got 6 here that have a dissimilarity of 1/9. So we're going to add 6 times 1/9. And then we've got 12 that have a dissimilarity of 1/15. So we get 12 times 1 over 15. And if we add all that up, we get 72 over 45. So 72 over 45 that's our tentative measure. We're going to have to change this a little bit. Because what does that mean? What does 72 over 45 mean? Is that bad? Is that good? So let's go through and let's sort of put our measure through the paces. So whenever you construct a measure, what you're trying to do is do some extreme cases to see how well it works. So let's start out with a simpler case to see if this measure sort of makes sense. And I've got 4 blocks that are 4 blue, 4 all yellow. And here's another case where I've got all 8 of them are 50-50. And let's compute our index of dissimilarity in each of these cases. So let's start with this one. Well, in each one of these blocks, there's going to be 5 blue, right, and 5 yellow. The total number of blue and yellow, right, since I've got 8 blocks, I've got 80 people, so that means there's going to be 40 blue and 40 yellow. So for each one of these blocks, I get 5 over 40 minus 5 over 40, which is 0. So every single block contributes 0, and my total index of dissimilarity is 0. So that's great, right? Because that means that if everyone was perfectly mixed, my index would be 0. So it seems like it's a pretty good index. But let's go back and look at this other case. So now I've got this case where I've got 4 that are all yellow and 4 that are all blue. So once again, I've got 40 yellow and 40 blue. But now I've got to think for each one of these yellow districts, what do I have? I've got 0 over 40 blue minus 5 over 40 yellows. Right? I'm sorry, 10. 10, so I've got 10 yellows in each one. So 10 over 40 yellows. So what that means is that's going to equal to 1/4. And since all these are the same, I'm going to get a fourth, a fourth, a fourth, a fourth, and so on. And also for the blues, right, by the same logic. So every single one of these is going to give me a value of 1/4. When I add all those up, I get 2. Right? I don't get 1, I get 2. So now I've got a bit of an issue. So if people are perfectly segregated, I get 2. And if they're perfectly mixed, I get 0. So this suggests I've got a pretty good measure here, but what I probably want to do is I want to divide it by 2. Right? So if I divide it by 2, then if you're perfectly mixed, you get a score of 0. And if you're perfectly segregated, you get a score of 1. All right? So if I go to this case, where there's 40 rich, 44, and they're perfectly mixed, my score is going to be 0. Because I get 5 black and 5 yellow in each district. Oops, this should be a 5, right? And so I get a score of 0. And when I do the other one, I get a score of 1. Now, when I look at my thing here, when I got 72 over 45, which didn't make any sense, now that's 72 over 90. And if I divide this by 9, that's going to be 0.8. So that's 80%. So sometimes this is 80% segregation, which seems pretty segregated. Now we can go back and we can look at our cities. So now we can go back and we can look at our census data and we can look at a city like Philadelphia. We can ask how segregated is it. And notice, look at what we get, 0.8, exactly the same as our example. So this tells us the score in Philadelphia is 0.8. Now we can look at this map and say, well, how segregated is it? Now we have a score. And now we can do things like compare Philadelphia to Detroit. So remember, Detroit also looks segregated. Well, when you do Detroit, even though it looks sort of as segregated, the score is only 0.6. So Detroit is actually substantially less segregated than Philadelphia. Even though, look, if you look at these two pictures, here's Philadelphia and here's Detroit. It's very hard to tell the difference between the two. Okay, so what have we learned in this lecture? We've learned that we can construct a very simple measure called the index of dissimilarity. And by using that measure, we can compare how segregated different cities are. And now once we've got this measure in our pocket, right, we can use it to measure segregation by race, segregation by income, and all sorts of segregation. So it's a really useful tool to help us sort of take data and understand the world. All right, thank you.